All right, our next speaker will be Romain, telling us about new foundations for Coq IDEs.
Thank you very much. Hi, guys. So, yeah, for those who weren't here this morning, I'm Romain Tetley, and I'm the new hiree in the STAM team with Eve. So I'm a permanent research engineer who's working on IDEs for Coq, and particularly on VsCoq 2. And today I'll be discussing the foundations that we've been building to further maintain and develop VsCoq 2. So this isn't a bold statement on my part. Actually, this is the title of a paper from 1992. And the reason I thought it was interesting to put this out there is after discussing with the community and things like that, it seems that things haven't changed that much in the realm of IDs for Coq, at least in the sentiment that the community has been giving me, which is that it seems to be lacking strong IDE support. And that's a real shame because if we're going to use this for industrial applications and like that, we really need good IDs. So of course then I'm going to talk about how to develop a real ID, I suppose. And that starts with what really has changed since 1992. And I suppose one of the bigger things is, well, the LSP protocol. And when you develop IDs, a common idea is, of course, you need new language features such as completion, diagnostics, things like that. And it becomes very natural to imagine a separate protocol, a separate executable from your editor to handle these things, which we usually call a language server. And actually, it's also very natural to the Coq world, as in old papers they discuss this concept very well. So then that is separate from the IDE to develop these things. And in recent years, there's been efforts to standardize this through a protocol called the Language Server Protocol, so LSP for short. And very basically, it's quite simple, really. If you have a common editor and a user opens a document in that editor, the protocol will then send a notification to your language server, which is in this case called text document / did open with parameters, in this case the document that needs to be passed by the server. Maybe the user will edit the document and then a different notification will be sent to the server with the changes that need to be applied. The server will do its thing, maybe there'll be errors, warnings, whatnot, and the server will then send back a notification with these diagnostics and how to display them in the front end, so the editor. Now, of course, this applies very well to a common programming language, but the typical feedback loop for Coq is quite different, so you need to adapt LSP. And you could have the same scenario, but then you need to execute a proof, and of course you need feedback for that. So you would have the same thing, you open a document, you send it to the server, and then maybe you want to execute your proof by typically doing an interpret 2 point, something like that. So you will then need to create a new LSP verb. So in our case, we call it, for example, VsCoq / interpret 2 points, so to extend LSP, and we give it the position, the document, and the server will do its thing and send back all the information required to display a proof. So in this case, just a proof view, maybe some information on where to move the cursor and go on. Now, if you're following, you'll see that developing an IDE requires maintaining a structured view of a document model, at least. And in most instances, this is quite trivial, and then this is fine. The work is almost done. It's just a matter of plugging in. It's just a piping work, and that's great. But in the case of Coq, of course, maintaining such a model usually requires to execute it, in which there's quite a big problem because execution tends to be quite costly. So the solution we found to that is separating parsing from execution. So it could be that actually you couldn't do that because for some reason parsing your document requires to execute it, but this is not the case for Coq. And it's not a trivial task because, of course, the parser for Coq is extendable at runtime. So off the top of my head, like stuff like notations, are commands that can change the parser. And so this is supported since Coq 8.18, and we heavily rely on that for the development of VsCoq 2 to maintain that structured view of the document. And of course, if you go back to the idea of adapting LSP for Coq, then it becomes quite obvious that when you open the document, you edit the document, things like that, that only requires parsing and that would be the parsing stage of Coq. But then, as soon as you start executing stuff, then you go into execution mode. So I'm going to discuss a bit more VsCoq'2 in practice. And I mean, first, the obvious question is why VsCoq'2? There's a perfectly working VsCoq'1 at the moment. And I'd say the three main points is, well, first of all, VsCoq'1 does not have a real language server because it uses a hack to communicate with CoqTop and get the information. The codebase is becoming quite difficult to maintain and so needed some renewing, and that is mainly due to the fact that there's a bit of data technology in the front end, which makes it difficult to do dynamic UIs and things like that. So VsCoq'2 is organized in two modules, one of which is the language server, which is written no camel and uses a reactive programming pattern, which I'll come back to in a minute. And the client is written in TypeScript, so well, to work with vscode, of course, but using the React framework, which makes it easy to make dynamic, reusable, interactive UIs. In fact, it uses two independent web apps that have been completely independent from the extension and could be reused in different environments, even maybe the web, the goal view, and the query panel. The architecture of the language server uses low-level modules, such as the execution manager, a document model, to communicate with Coq. So of importance here, you have the execution manager that's going to communicate with the Coq vernacular and handle everything execution-wise. We have a little query module that handles queries such as search, locate, check, things like that. And we have our document model, which will communicate with the Coq parser. All these things use a reactive program pattern. They will create events which will bubble up and then get handled by the top level. So, and go through a LSP manager, which will handle everything LSP-wise. So receiving notifications, sending out notifications, receiving requests, handling them. Rather than blabbing on about it, I'd rather show you how this works. Very quickly, I'd like to give a demo. I don't know if I can display. Oh yeah, nice. Jesus, that's going to be interesting. So I'm going to do something a bit crazy. I'm going to run a development version of vsCode. There we go. This is going to be a little difficult. Wow.
Yeah, try zooming in. It's hard to read also for us. So.
Sorry?
In Control Plus or something like that.
Yeah, no, that's great. But I would really like to see. I think you need to turn on mirror. Yeah, I think that would be better. You're right. Okay, hold on a second. Yeah. Okay. Ah, there we go. That's way better. Okay. Let's just run this again. Yes. All right. Wow. That's a bit intense. Yeah, I'm falling prey to the typical demo effect. Sorry. This is way too big. And is this better? A bit smaller. Great. So I'm running an instance of VsCoq on a file that I'm using to teach engineers at the Inlia engineering team how to work with Coq. So at the moment, it's using a new sort of interaction model that maybe you wouldn't be used to, which is a continuous mode. It's running the document continuously, and if I move the cursor, it will trigger a goal view, which of course, right now you're not seeing greatly. So, if I open the user settings here, you can see that I'd like to demonstrate that these views are quite dynamic. In this instance, I'm displaying the several goals I have here, which are collapsible, but I could display them as tabs if I just change this little here, and you see it goes very fast, although, well, I'm sorry about the display, but this mirroring thing is just not working great. There's a few other stuff that we've implemented. So some students have implemented some basic version of auto-completion. So in theory, if I go here and I try to type unfold, abstract, transfer, it should come up as an autocomplete option. Other things I'd like to show you are maybe so we have a query panel implemented in which we can, well, search things, but also use other queries, like maybe locate, check, about, you name it. We can, of course, add tabs and remove them. And so I'm going to show you a new feature that actually we've implemented, last Wednesday within Code in Ria. You can see here I've got a warning triggered by the intros. And if I hover over it, you'll see that it tells me intros is fragile, that I need to specify the names. So this is, of course, because, well, we have an apply H later, and if we start refactoring this code, it could cause havoc. So if I hover over it, you'll see I also have a quick fix handled here. And when I click, it offers me already the option that I can then just, well, change, and there we go. It fixes your code. Wow, thank you. In fact, this is the great thing about this is because of the way we use the LSP protocol, it doesn't require to re-implement it each time. So now if you just change the Coq API and add new warnings with the correct information, it will work. So I can prove this to you. By the way, the interaction mode is, of course, changeable. I could go back to a more traditional manual mode, like in here. And then I could do interpret to point here. So in this case, well, here Enrico, I think 2 days ago, implemented a new warning, which is we create a module, we try to do extraction on it. Of course, it's ambiguous. And once again, so he only corrected the Coq API to add the correct information. And if I click on it, then I'm going to get, well, both infos, and I can just click, and there we go. So I hope I've convinced you that this refactoring was actually worth it and makes it really easy to implement new features. I think that's about it for the demo. Now I'm going to try and find my, there we go. And to give you a rough idea of where we are at the moment, so we released VsCoq in September. There's been 3 minor versions since then, and we're working on some stabilization at the moment, and we hope to roll out quite a lot of new features after March and in the coming new year. So you'll see quick fix, probably also stuff like jump to definition and things should come quite quickly. I think I'd just like to conclude and give you an idea of what we'll be working on. And if I had to give you some take-home messages, I hope that I've convinced you that VsCoq 2 is at least better maintainability than the VsCoq 1. That LSP support allows for easier language feature development, as I hope I've demonstrated, although poorly because of this little mix-up. And well, it's of course an open source project, so contributions are welcome and encouraged, so please come help us. And in terms of further work, as I said, for VsCoq 2 itself, we'll be focusing on debugging and stabilization in the coming months, and then new features soon. But I'd also like to talk about Coq and LSP. So for Coq, I think there needs to be improvements in the API, and this is something we should do together, at least to know what the warnings should give us. Maybe we could specify this. This was a proof of concept in this case, but this should be clearly specified. Having locations of functions would help us well do everything like jump to definition, better autocomplete, and things like that. And to display the goals in the front end right now, we're using a really hacky solution because we use quite a dated system, and it would be really great to also specify the information we want to display in the front end as goals and how we send them through the protocol. For LSP, I think this call has already been made before. I think probably by Emilio, he'll correct me if I'm wrong, but it would be great to standardize the extension to LSP for interactive theorem provers. I think the extension that we've used could be standardized to include other theorem provers in the long run. And I'd say that's it. Thank you for listening, guys. And if you have any questions, I'd be really happy to answer them. Thanks.
Thanks a lot, Romain, for the talk and for daring the demo gods. They were partially with us, I guess.
Didn't go too well, man.
Well, I mean, we got a demo, so could have been a lot worse. I've seen much worse.
Hi, thank you very much for the talk and for the tool. Very nice refactoring with this intros. Could you please do the same for like proof using?
That's really, really funny you should mention that, because that was the thing we were working on, like, I believe yesterday with Enrico. Like, that's the third thing. We were thinking of stuff to show. One of it was intros, one of it was the module thing, and the other one was proof using. So yeah, definitely, it's the idea is to do it, yes.
Thanks. How soon do you expect?
Probably next week. I don't know, man. Like, it really depends on when we roll out the next release and if we plan to introduce the quick fix, because it's not just a matter of changing the VsCoq in this instance, it's also changing the Coq API itself.
Okay, thanks.
Yeah.
Again, thanks for the talk. I just want to ask, so since multiple editors support LSP, not just VsCode, could we use this in Emacs and possibly to replace Proof General?
Yes. In fact, I believe there's already been an effort to make it work with them. I can't tell you the exact name of the repo, but it has been done, yes.
So this is IDE part. Have you thought about any tie-up for the documentation? So you can.
Yeah, that's a loaded subject, man. But yeah, I did. It's an ongoing thing. It would be great, yeah, to have included documentation with it, and probably some tutorials as well, directly included in the panels, probably as a web app or something. So yeah, there's some thought to it. I wouldn't say work yet, but hopefully soon, yeah.
To add to that, like in other languages, I can hover over a function name and it shows me like this doc comment thing, which is like modern technology from the 90s or something. Could we have that for like comments we attach to Coq definitions via whatever syntax we need for that?
Yeah. It's also something we'll be working on, and part of it is also changing what information we want to transmit through the Coq, through the protocol. But yeah, of course, yeah.
Sorry. So this is great. I'm very excited to see that. I think we'd love to move Proof General away from what it's currently built on. So that would be great. It's more a suggestion than a question. There's actually a lot of features in Proof General and the extensions that exist to it. So the automatic intros, Proof General does. The automatic proof using, Proof General does as well. And so I think at some point taking, and it's fairly decently documented, to taking that list and having that as a checklist would be very helpful, I think, to help some of us move away from that.
Thanks, man. I'll take that to heart.
Wow.
Maybe just scream the question. I don't know, man. Like.
So the degree of speed in this demo was very impressive. Have you had any examples where you have Coq proofs that are really slow, and what does that do to the user interaction? Like on the order of hours or days for normalization?
Days,
Some
Jesus
of us
Christ,
have
man,
that
come
as
on.
part of our experience.
So yes, there's definitely issues with some files. Not gonna lie, it has been a problem. And what I would usually say in those instances is go back to manual mode. Like, this is why I think keeping both is a good idea to some degree, and probably making it more, at the moment it requires to go in a menu to change it. At some point I was thinking of making that change with a shortcut or seamless, so that to make it easy for those instances. Yes, definitely.
Okay, thank you.
Let's do one final quick question, and the next speakers can already start setting up.
Thank you for this work. It's very nice. I'm a proof general user, and I would really like to switch to VsCoq. There are several things that have stopped me from doing that. One of them is the stability, which you're working on. Another one is that I really like that in Emacs I have a lot of shortcuts. Like for queries that you showed, I don't want to open a separate window to make a query. Can you do that?
Sure, I was actually discussing that very same thing with someone else here earlier today, but yeah, we can do that, and we're working on it. So a lot of these shortcuts are already, in theory, implemented. We just need to plug them in. Oh yeah. Thanks.
Okay, one final quick question.
So I'm going to mention Lean. Lean has an LSP server and an Emacs mode that uses that LSP server. Can we reuse that and their LSP API as well, or not?
Sorry, can you repeat?
Lean 4 has a built-in LSP server, and it's also a proof assistant, and they have an Emacs mode. And so in the spirit of unifying, how far is our API from their API? And could we reuse their Emacs mode directly? And their VsCode mode and so on.
You want to use the Lean 4 server with Coq?
No, I want to use the same protocol as Lean uses.
Yeah.
So that because when I use Python or JavaScript or something, I don't install a specific mode typically. I just load the LSP server.
So you're asking if you can reuse that language server with a different editor?
Their editor UI with a different server. Could our Coq server speak the Lean LSP protocol?
Well, that goes along what I discussed in the final slides, which is we would need to standardize the extension to the protocol, and in theory it could be possible, but at the moment I don't think so, no.
All right.
All right, let's thank our speaker again.